the largest partitions, really, in Active Directory. It contains groupings of security principals. Security principals in Windows 2000 are users, computers, and groups. Groups can contain users, computers, and other groups, of course. Anything that has a security identifier, a SID, is a security principal in Windows 2000. You grant access to resources to SIDs. When you look at an ACL and you see a list of who can touch this item, you are seeing friendly display for SIDs. Under the covers, it's all SID-based. SIDs are not the same as GUIDs. Everything in AD has a GUID, a globally unique identifier, which is an identifier that's generated when the object is created. SIDs are purely security related. Also, SIDs can change in Windows 2000, which we'll talk about a little later, briefly. You can assign permissions to resources to anything that has a SID. File system resources, things like shares, printers, files, and Active Directory objects as well. When you build Active Directory, because it is a directory service, you are creating objects that represent the actual components of your network. Objects that represent the shares, represent the users, represent computers, represent printers, and so forth. Well, those objects have their own ACLs in terms of what can somebody see in your directory. By default, everybody can see pretty much everything as far as the base properties for objects in Active Directory, and those are things you may want to change. But remember that the objects are not the entities that they represent. You may have separate ACLs for some of these things. The domain partition contains a lot of objects that organize other objects. Organizational units, which by the way are not security principals, they do not have SIDs. You cannot grant permissions to OUs in Active Directory, as you probably know. Organizational units are used to collect together and to organize security principles in your environment and objects in your environment, whether it be for purposes of delegating administrative authority or whether it be for purposes of applying group policy, and it's usually a combination of both of those. Also, DFS structures are stored in the domain partition. Do you know what DFS is? Good, thought so. DFS, distributed file system, allows you to take multiple shares on multiple servers in your environment and represent them as a single logical tree for your users. This is something I find kind of underused in a lot of environments. Rather than moving shares and letting your users know that share X is now on server Y, you should be using DFS, which allows you to abstract the actual shares and servers that your users are accessing. You can map for them a root drive to the DFS structures. They really have no idea under the covers what they're accessing. Also, Microsoft is finally trying to get away from network neighborhood, browsing the network. Browsing is ugly, it's inaccurate, it's noisy, so don't use it. The goal with 2000 or later is to use the directory, to allow your users to issue queries against the directory to find things that they're looking for. DFS gives them a very comfortable interface to work with, an explorer interface, to essentially what they think is browsing the network, when in reality they are not. The DFS replication topology itself is what is stored in the domain partition. There are two types of DFS in Windows 2000. There's a standalone DFS and there's a domain-based DFS. A standalone DFS is the same as what was available in NT4, where you have one server that is taking all of these shares and representing them in a single tree. With a domain DFS, you have multiple servers hosting that structure, that abstracted representation of the shares on your network. And those servers will replicate changes to that topology, to that structure. Now, they may or may not actually replicate the contents of those shares. That is entirely up to you, and it's very customizable. But be aware that there is not an inherent tying in of contents replication and DFS replication. What is stored in Active Directory in the domain partition is the replication structures for the DFS architecture itself. Other things in the domain partitions. When you publish shares or printers, now printers are published by default, shares are not. When you publish a share or publish a printer in the directory, what you're doing is making it possible for a user to run a query against the directory and find a printer or find a share based on criteria that they specify, hopefully, as opposed to show me every share on the network. The shares and the printers that are published as objects, those objects are entirely separate from the actual shares and printers themselves. A user may have read access to a share and not have access to the object in the directory or vice versa. It's important to kind of keep a consistency between permissions on the shares themselves and permissions on the objects you're using to represent them in Active Directory. If a user is not supposed to be accessing a share, then don't give them read permission to the object that represents it. That way when they run a search, they never see that it exists. It cuts down on the noise level and the attempts to access things that people should not be accessing. Other things that are stored in the domain partition, and this one's important. AD integrated DNS zones. When you create DNS zones in Active Directory or in Windows 2000, you have several choices in terms of how you can create them. You can create standard primary zones, standard secondary zones, and if the machine that is running the DNS service is a domain controller, you can create an Active Directory integrated zone. Because this information is stored in the domain partition, Active Directory integrated zones do not replicate to domain controllers for another domain. One of the biggest mistakes I see people make is assuming that they can have two domains hosting the same AD integrated zone and that everything's going to replicate between them. And I've heard people say AD integrated zones don't work because they've tried to do this. You have to be very aware that if you have two domains that are hosting AD integrated zones, eventually they're going to be out of sync. Each of them will get updates from clients that are pointing to them, but they never talk to each other. So if you want to host an AD integrated zone and you have domain controllers in another domain that you want to replicate that content, you are looking at having to set up standard secondaries in the other domain. In one domain it's AD integrated, in the other you use standard DNS methodologies. This will change in .NET. There's an additional partition in Active Directory in .NET called the application partition, at least tentatively. And it was expressly created for AD integrated zones because this has been a problem. People don't understand that they don't replicate across domains. With an application partition, you can specify which domain controllers in your entire forest will contain that AD integrated DNS information. Therefore, you won't have to worry about domain boundaries being a restriction in terms of the replication process. Also be aware, and I think you probably know this, AD integrated zones do not have to represent the domain in which they're stored. For example, I could have two domains, blue.corp and red.corp. My red.corp DNS servers could hold AD integrated zones for both red.corp and blue.corp. Just like in a regular DNS implementation where your DNS server doesn't have to be a part of the domain it represents, in Windows 2000 it doesn't either. And you may centralize your AD integrated zones into one domain. But there is no one-to-one mapping of DNS AD in Windows 2000. The configuration partition replicates to every domain controller in your forest. When you establish a forest, when you first build Active Directory, one of the partitions that is going to be common to every domain controller you create is the configuration partition. It is essentially the map of Active Directory. It is the container or the piece of Active Directory that contains domain information, which domains exist in your forest. Trust relationship information, which trusts exist via normal transitive trusts being created as part of the AD installation process, what shortcut trusts have been created, what external trusts have been created. Domain controller locations are part of the configuration partition. Where is domain controller A versus domain controller B? And this is because this is used for generation of the replication topology. Additionally, site and subnet information is stored in the configuration partition. Subnets and sites are how you tell Active Directory what your network looks like. There's no such thing, by the way, as a redundant site link. Have you heard of this? No? Okay, good. That's actually a pretty common misconception. Redundant site links, I've heard people say, well, I'm going to have two ways set up to get out of this site for replication purposes, so that if my T1 line is gone, something happened to my T1, we can use this other link to get out of this site and still continue to replicate. It doesn't work that way. AD has no mechanism for determining the actual physical path a packet takes to get to another domain controller. What AD does know is what you tell it about the connectivity of your environment. Where do you have machines that can use RPC and quick communications to talk to each other? Where will they have to look at slower communication links? Because the configuration partition is replicated to all domain controllers in the forest, and it is the same for all domain controllers in the forest, this is a fairly security-sensitive partition. As a result, most of the manual changes that you can make, things like authorizing DHCP servers or creating sites, most of these things by default are restricted to enterprise admins in terms of who's allowed to do them. You can delegate this out, but be aware that for the most part, at least on the surface, these things look pretty restricted. The reality, however, is, as with any environment, local access to domain controllers blows it up. If a domain admin sits down at a domain controller, that domain admin can make modifications directly to the configuration partition and bring down your entire forest. Not just his own domain, but every other domain as well, because of the fact that this is a single shared partition amongst all of your domains. Excuse me. Now, he could do that by installing intentionally a hack application of some sort, or even poorly written applications that were not written according to Windows 2000 specifications, do things they shouldn't do. When you install this application on the domain controllers have full access to the configuration partition. They can write whatever they want to it, and you may have just blown up your entire forest. Microsoft has started to discuss this a little bit, but originally you heard a lot of domains as security boundaries in Windows 2000. The reality is, because of this and a few other items, that's not really the case. You should not consider domains to be security boundaries unless you have mechanisms in place to ensure that they are security boundaries, which we will be talking about. The schema partition is the second partition that is shared by all domain controllers in the forest. Again, the schema is essentially the template for your forest, for Active Directory. It is the definition of the objects that can, or the types of objects that can be created in your directory, which attributes are associated with those objects, which attributes replicate to the global catalog, which we will discuss. Consider keeping your schema master offline. Do you know what the schema master is? It's the one domain controller that is allowed to write to the schema once it's been created. By default, it's the very first domain controller you build. When you run DC promo on the first machine in your environment, you are building the configuration partition, the schema partition, and the domain partition for that domain. The schema master, once you enable writes on the machine, can make changes to the schema. Because of this, you may want to keep it offline, bring it up maybe once a week periodically so that it can replicate with the other domain controllers, but so that it's not accessible, so that there aren't accidental or intentional but malicious modifications to the schema. Never modify the schema with the schema master connected to the network, ever. When you modify the schema, the changes you make will begin to propagate out, and you cannot undo them in Windows 2000. There is no such thing as an authoritative restore of the schema. In Windows 2000, if you blow up something in the domain partition, you delete an organizational unit that has 5,000 users in it, you can bring the domain controller down, perform an authoritative restore on that OU and all the objects inside, which is going to mark their update sequence numbers, their version numbers, by it's a value of 100,000 per day since the last backup. So you restore from a backup, increment the USNs, and these objects are now considered the newest versions of these objects. When you bring your DC back online after performing this authoritative restore, now that information replicates back into the directory and is not deleted again. You can't do this with the schema. Therefore, if you are modifying the schema and it's online while you're doing it and you goof, it's over. You're now looking at having to rebuild everything from a backup, every domain in your forest. Keep it offline when you modify. Also, right before you modify the schema, make sure you back up that machine, because the only way you're going to get things back is to restore from that backup. It's not the same as an authoritative restore. You're not doing anything to mark it for replication purposes. You're saying, I goofed, I blew up the machine, and putting it back to ground zero again. But do not do it while it's connected to the network. In .NET, you will be able to undo changes you make in the schema, but don't rely on that as a fail-safe, obviously, because it's not always what it's advertised to be. Domain controllers. Every domain controller in a forest, regardless of how many domains you have, contains a full copy of the configuration partition for that forest. It knows everything about the map of Active Directory. Where are the domains? Where are the trust relationships? Where have we defined sites? Where have we defined subnets? It has a full copy of the schema partition for the entire forest. What kinds of objects can we build in our directory? It has a full copy of its own domain's domain partition. It knows about all of the objects in its domain. It does not, however, if it's just a DC, know anything about other domains' domain partitions. My domain knows nothing about your users, your computers, your OUs, your group policies. I only know my own. Global catalog servers, on the other hand, have a little more knowledge. Global catalog servers are domain controllers. Technically, it's possible to build a global catalog server that is not a domain controller, but nobody's done it. Because these machines are domain controllers, they have a full copy of the domain partition for their own domain. They have a full copy of the configuration partition. They have a full copy of the schema partition. They also have a smaller read-only copy of every other domain's domain partition. Now, how it's smaller? They have a copy of every single object for each of those domains, but they don't know everything about the object. For my own domain, I know everything there is to know about a user object. For your domain, I know common things about the user object. First name, last name, logon name, these kinds of things. You can define which attributes, which pieces of information get stored in the global catalog. Be aware, however, when you do that, when you include an additional attribute in the global catalog, all of your GCs are going to reset all of their USNs to 0 and rebuild everything they know about the other domains in the forest. So this will generate some heavy replication traffic in a production environment. Active Directory replication. The primary thing to remember about replication is domain controllers replicate partitions that they have in common. Therefore, any two DCs in a forest could potentially replicate the configuration partition with each other, whether or not they belong to the same domain. They can replicate the schema partition to each other, whether or not they belong to the same domain. If we need replication of the domain partition and we are both domain controllers, then we have to be domain controllers for the same domain, because I don't know anything about anybody else's domain partition. Global catalog servers can replicate actually directly with each other partitions that they do not own, or they can get them from domain controllers that own that domain. And that's not really a very well documented concern. I think there's one paragraph in the resource kit in one of the books about it. But what this means is a global catalog server in a site can collect domain partition information for all of the other domains where there are domain controllers in this site, and it can directly pass that information to a global catalog server in another site without that other global catalog server having to talk directly to the additional domains itself. What a GC cannot do, however, is pass updates to partitions it does not own to domain controllers that do own those partitions. So if I am a domain controller for domain red, and you are a domain controller for domain blue, and I'm a global catalog server, I do have a copy of your domain partition, but I cannot give you any updates to that domain partition. I can only get them from you. And here's what I mean. Now, I am not a very skillful PowerPoint person, as I discovered this morning when I opened up my slides and realized that I can't tell colors either, and I had this domain blue partition labeled red. In this scenario, I have 4 domain controllers. There's domain blue DC1, it is not a global catalog server. I have domain blue DC2, which is a global catalog server. I have domain red DC2, which is a global catalog server, and domain red DC1, which is not. In terms of what can replicate, first remember that replication is always a pull process. Whether we're talking intra-site or inter-site replication, the receiving domain controller is pulling changes from the domain controller that has the updates. So in this environment, this domain blue DC could pass schema information to another domain blue DC, to domain blue DC2, which is a GC. That schema partition information could then be passed on to a domain red domain controller, whether or not it's a global catalog server. The likelihood is you will see these things replicating amongst domain controllers for the same domain if they exist in the same site. That's the most common automatic generation. I can see the configuration partition follow the same path. Configuration information can cross between domain controllers for different domains because of the fact that it is a single shared partition. Now in this scenario, domain blue DC1, domain blue DC2, both being domain controllers for domain blue, obviously have the ability to fully replicate information back and forth between them. Either of these domain controllers could write to the blue partition and pass those pieces of information on to its partner. This domain red GC, the global catalog server, can get information from a domain blue DC or from another global catalog server, but it cannot pass the changes it has received on to another domain blue domain controller. Domain blue domain controllers have to get that information from domain blue domain controllers. For the domain red partition, these 2 DCs in domain red can replicate, and I could see this domain red GC passing information to the domain blue GC. Clear? Good. What I will not see, what will not happen, is that global catalog server that is a domain controller for domain red will not feed changes to a domain blue DC. I will not see the domain blue GC feed changes to the domain red DC. If I don't own it, I can't officially replicate it, except to other global catalog servers. Trees in Active Directory. Trees, everybody tends to know what a tree is, but they tend to have kind of a misconception about how big a tree has to be. Trees are one or more domains in an Active Directory environment that share a contiguous namespace, meaning the root of the tree, the first domain created in this particular tree, serves as the base of the DNS namespace for any child domains. A single domain is a tree. If you're familiar with Jeff Foxworthy, he has a saying about a redneck family tree: it doesn't branch. Active Directory can be a redneck implementation. It may not branch. You can have a single domain, and you have a tree, you have a forest, just a little one. Domains in a tree are referred to as parent and child domains. The reality, however, is that's as far as the parent-child relationship goes. There is no inherent parent functionality between a domain that's higher up in the tree than another domain. Domain admins for the tree root don't have any power in the child domains. People commonly think that they do. The reality is they don't. If you're a child domain, you and I could be separate domain trees and have the exact same functionality. Now, where you will see cross-domain functionality is when you're talking about site-level policies, which enterprise admins can implement, and some enterprise admin functionality. But parent-child relationships between domains, it's only the namespace. Forests. Yes?
One quick question. Mm-hmm. Inside the same domain space, there are trust relationships. Is that,
we're going to be talking about it.
Mm-hmm. Okay, sorry.
A forest, when you establish a forest, you're building the configuration partition, the schema partition, and your first domain's domain partition. The forest is always referenced by the root domain as far as naming it. That's the first domain you create. Your root domain does not have to be what I call a production domain. You can create an empty root, which is a placeholder domain. You establish your first domain that has some very powerful groups in it, and then you leave it out of your production environment. It still has to be online. It's still got to be there for querying and for DNS and some of the base functionality of Active Directory, but you don't populate it. You don't put users into that domain. You don't put computers into that domain beyond the default objects. And then you use political mechanisms to control who can touch that domain in any way, shape, or form. In Windows 2000, you cannot establish transitive trust between forests, meaning in a single forest, one of the things that is shared by all domains is transitive trust relationships. If I trust you and you trust him, I therefore trust him. However, between forests, there is no transitivity. If I have forest A and forest B, and a domain in forest A chooses to trust a domain in forest B, that is a trust relationship just like in NT. It's between those domains only. In .NET, you will be able to establish forest-to-forest transitive trust relationships, but not yet. Also, you should consider the uniqueness of your root domain name. Rather than doing like 99 out of 100 people will do when they create an empty root and calling it root.ad, make sure, or try to make sure, that the name you use for your forest root is unique. Whether it's something you've registered and you never intend to use, you shouldn't be exposing this stuff on the internet. Or whether it's something that is just so out there that you know nobody else is going to use it. Not because we're concerned about DNS resolution, not because we're concerned about internet access, since that shouldn't be happening, but because we may be concerned that in the future we merge with another company and we want to establish trust relationships between our forest roots. If they have the same name, we can't. In 2000, you can't rename. In .NET, you will be able to rename, but it is not a pretty process. It's still a create and populate process. It is lengthy. It is more work than it's worth if you had appropriately named your root domain in the first place. In 2000, you can't delete this domain and you can't rename it. So be very cautious with that first domain. Sites. Sites are collections of well-connected machines. What well-connected means is relative. You decide what is well-connected for your environment. If I am establishing Active Directory for Jim Bob Billy Joe's garage, where he fixes cars and he's got another computer in his house, and he's got DSL connectivity between his house and his garage, his garage where he fixes cars, then I may consider that to be a single site. I may consider that adequate replication or adequate pipe for replication. Depending on who you talk to, 10 megabits may be listed as the minimum for site connectivity. That's not always the case. What you would normally call a LAN is probably what you would consider a site. Sites define good connectivity. Subnets are associated with a site. Once you've established sites in Active Directory where you've said we have these areas of good connectivity, you tell Active Directory which subnets belong to that site. A subnet doesn't span sites. I don't have a subnet that belongs to site A and site B. It's one or the other. Now what this facilitates is client computers, when they start up and they get an IP address from a DHCP server, based on the IP configuration they have, they are associated with a specific site. Based on the site they're in, they may get different policies. Domain controllers can be associated with sites either manually or automatically, and what I mean by this is if you set up the sites and subnets before you start building all of your domain controllers, they automatically appear in the appropriate spot based on IP address. You can manually move them. It's 6 of one, half a dozen of another. Sites are used by the KCC, the Knowledge Consistency Checker, to develop a replication topology. Within a site, replication is assuming that you do have fast bandwidth. It is uncompressed, it is RPC-based, quick replication processes. The disadvantage to this is it uses more bandwidth than it would if it were compressed traffic. The advantage is you don't have the processing load of compressing the traffic. Between sites, connectivity is assumed not to be good. Therefore, when traffic exceeds a 50K threshold, it's roughly 50K, that traffic is going to be compressed. And it is compressed to 10 to 15% of its original size. So when a domain controller in site A is replicating whatever it's replicating with a domain controller in site B, and it's got 50K or more to send, it is going to compress that down to be around 5, 6K. The advantage is we're not sucking up the pipe. Disadvantage, there's processor utilization involved in doing this. Also, between sites, you can schedule replication. It's not like NT where you had to tweak 18 registry parameters and kind of sort of make replication happen at a certain time of day. In Windows 2000, you really can say, this is when replication is permitted to occur. This is when that window is open for domain controllers in this location to talk to domain controllers in this location. You do that by building site links. Be aware that site links and connection objects, if you're looking in AD sites and services, are not at all the same thing. Connection objects are one-way traffic flow representers in AD. When you see a connection object under DCA that lists DCB, it means DCA gets information from DCB, period. People tend to think that by establishing site links, they are specifying which domain controllers are going to talk to which domain controllers. Unless you know which partitions are hosted on which domain controllers, you really can't predict this. So you want to be very aware of who owns what in AD. The forest root domain, I've mentioned some of this already. The forest root domain contains some of the core information that structures your forest. It is the domain that builds your forest. The schema is established there, the configuration is established there. Some DNS functionality requires the root domain as far as being able to locate. Trust relationships all go by default to the root domain in some way, shape, or form. And I will be talking about this shortly. You cannot rename it now. You will be able to in .NET. It is still not a desirable solution. You can't recreate it if you lose it. However, since I'm sure you do regular backups, that shouldn't be an issue. You cannot establish trust between two root domains with the same name, even in .NET. Forest design. For those of you who have implemented AD, how many of you went with a single domain? Good. 1? 2? Okay, be aware with a single domain, you do have some fairly large security concerns. The forest root domain contains the enterprise admins and schema admins groups. Enterprise admins are the people who can write to the configuration partition, even if they're not sitting physically at the domain controller installing an application at the time. Schema admins are the only people who can make modifications to the schema. Well, in your root domain, domain admins can put themselves into either one of those groups. Also, by the way, enterprise admins by default are in the administrators group in all of your domain controllers in the forest. This is what gives them enterprise-wide functionality. So if you have a single domain, your domain admins might as well be enterprise admins and schema admins, because all they have to do is put themselves in the group and they're ready to go. That means you need to look more carefully at how you start to lock out some of these accounts, or how you start to control access to some of these accounts. You may want to require a smart card logon, biometric logon for these accounts, keep the cards locked up. There's one company I work with that actually none of their administrators have domain admin accounts, and this is not a bad idea. In any of the domains they have, no domain admin accounts. When they want to use a domain admin account, they have to go to the head of IT, his office. They have to check out the smart card, be physically accompanied to the server room if they need to be in the server room making this change. They make the change, they return the card. And I'll explain more about why you don't want to give people domain admin rights, even if they are domain admins. Don't make them members of domain admins. Physically secure your root DCs, physically secure any domain controller because of that ability to modify the configuration partition. You should not sit at domain controllers to do work. You should not be spending your day in the server room. You should be spending your day at your desk in a perfect world. The root domain name does not have to be contiguous with your production namespace. This is something people commonly think they have to do, that they have to call the root this dot that and their production domain something dot this dot that. Absolutely not true. Your root domain can be called this dot that. Your production domain, or the domain where you actually create users and computers and so forth, can be called whatever you want it to be. They are separate trees, but it's still the same forest. And a lot of documentation that's floating around out there is very heavily dependent on this parent-child namespace. The reality is that may not be the most efficient way to go, which I'll talk about in a little bit. It's coming up. Locking out enterprise admins. Since I mentioned that the enterprise admins exist only in that forest root domain, by default they are members of the administrators groups on all of your DCs. There are some white papers out there floating around talking about how you can lock out enterprise admins. The reality is you can't. You can get pretty close, but by the technology itself, you can't. If you want to lock out enterprise admins, you're looking at political mechanisms. The reason for this is, first and foremost, enterprise admins can set site-level policies. They're the only people by default who can. So if I can set a site-level policy, I will set a policy for every site that puts me into the administrators group on every single machine there. Done. I'm right back where I was before, even better. Now I'm on every machine. And you can't stop me because I'm the enterprise admin. Even if you try to do things like restrict my ability to set these policies, there are processes in Active Directory that will run and give me back permissions on some of the pieces of the database so that I can still go back and create these site-level policies. If I have the ability to log on or to authenticate as an enterprise admin, you're not going to lock me out, and it's not going to take much for me to get past that. Namespace design. Don't get hung up on contiguous namespaces, as I was just talking about. Don't assume that you have to set up a single tree with a root domain that is a parent to child domains. There does not have to be a contiguous namespace, period. There is no functional difference between domains that are in two separate trees and parent-child domains. In addition, the trust path may actually be shorter in a multiple tree design, and I'll show you this shortly. Actually, I'll show you this right now. In this design, here I have two trees in my forest. I have forestroot.corp, tree1.corp. These are not contiguous namespaces. People sometimes think that just the suffix, the TLD, is going to make these contiguous namespaces. They're not. If I call that tree root forestroot.corp, child domains must end in forestroot.corp. Therefore, tree1.corp is not considered contiguous. So each of these domains has two child domains, child1.forestroot.corp, child2.forestroot.corp, and child1a.tree1.corp, child2a.tree1.corp. This is one of my least favorite things about parent-child relationships, is these long, ugly namespaces. And you also have to be aware of what is the NetBIOS name of the domain going to be, and make sure that's not duplicated. That can be problematic. Now in this scenario, I have a computer in child1.forestroot.corp and a user in child2a.tree1.corp. For the computer to authenticate the user, it has to follow the trust path as defined in the configuration partition in order to obtain Kerberos tickets for that user. So first, the domain controller is going to authenticate, or the client computer is going to authenticate in its own domain. It is going to follow this trust path up to its parent domain. The parent domain has a trust relationship with the forest root. In this case, we've got, let's say, tree 1 is our forest root. There's nothing visually to indicate this. The next ticket that this machine is going to obtain on behalf of the user is going to be for the Kerberos service in tree1.corp, which is going to allow it to then go to child2a.tree1.corp to get a Kerberos session ticket for that Kerberos service. Then we actually get a session ticket for a server if we want to access something. But in the case of authenticating this user, users are always authenticated by domain controllers for their own domains. Sometimes people think global catalog servers perform authentication. The only time a global catalog server authenticates you is if you're a user in the domain for which it is a domain controller. So a user logging onto this machine, the trust path is going to have to go child to parent to root to child in order to get that user authenticated. On the other hand, if we have non-branching trees, we have a redneck implementation. My forest root in this case is forestroot.corp. I have 5 separate trees, tree 1.corp, tree 2, tree 3, tree 4, tree 5. If the user's account is in tree 2 and the computer is in tree 5, in order to authenticate the user, the machine is authenticated by a domain controller for its own domain. Following the Kerberos trust path, goes through the forest root, gets a Kerberos ticket granting ticket for that domain, then goes to the domain where the user account is located. No domain is ever more than 2 hops away from any other domain in this scenario. And what that means is you don't have to do things like establish shortcut trusts because these child domains are so far away from each other in your domain hierarchy. And you have shorter DNS namespaces. Make sense? Okay. Global catalog server placement. GC's global catalog servers are required for several functions in Windows 2000. First, global catalog servers are queried when you use UPNs to log on. They're also used primarily for LDAP queries when you're looking for resources. Even though the GC may not be the machine that authenticates you, you should have at least one global catalog server in every site, because you want them to be able to collect changes and act as bridgeheads to other sites. Also because they're going to be needed for things like Outlook. If you use Exchange 2000 and you use Outlook, you better have GCs all over the place. They really like them. Be conscious of which partitions live where as far as your sites. Now, the logical structure of AD, which domains you have and which trees and forests and so forth that you have, is separate from your pseudo-physical structure, in that I could have domain controllers for 10 domains in this site, and in site B, I only have a domain controller for a single domain, or I have 10 domain controllers for a single domain. What I need to be conscious of is what information is in each of these sites that needs to replicate throughout my environment, and to which sites will it need to replicate? Where do I have shared partitions? Microsoft is kind of pushing a little lately for making all of your domain controllers global catalog servers, and depending on your environment, it's really not a bad idea. If you have a single domain, when you make your DCs GCs, all you're doing is opening a port. If you have multiple domains, if you have an empty root and a single production domain, you're actually adding minimally to those domain controllers by making them all global catalog servers. This is because in an empty root scenario where you aren't using your root domain for production, it's very small. It's around 1620 megs. And hopefully it doesn't get too much larger than that. So you're not greatly increasing the size of ntds.did. You're not greatly increasing replication traffic because there isn't that much happening in the forest root. With an empty root single domain environment, you might as well just say all of my DCs are GCs. Also in a single domain environment, you might as well do it. And in environments where you have several domains, it still may be something to consider. Investigate it. The infrastructure master role. People have heard about this, how the infrastructure master should not be on a global catalog server. The infrastructure master is the one domain controller in a domain that is responsible for updating user to group references when you move objects from one domain to another. There are 3 reasons that I know of that have been given why the IM cannot be on a global catalog server. 2 of them I can tell you. One is, and this is the published reason, one is in terms of the infrastructure master, it's supposed goal in life is that it's supposed to be cross-referencing objects. If it's a global catalog server, it knows everything, sort of, about every domain in your forest, therefore there's nothing to cross-reference. So this is why you're told not to put it on a GC. Reality, or what I've seen, is in a production environment, having the infrastructure master on a GC while you're doing a lot of migration, it overloads the machine. It's heavy processor utilization. It will chew up that box for a while. Third reason, hit me offline. If all of your domain controllers are global catalog servers, you can have the infrastructure master on a GC, and that's documented. DNS servers. DNS servers in Windows 2000 don't even have to be Windows 2000 boxes, as you know. If they are Windows 2000 boxes, they can be domain controllers, member servers, or standalone servers. They are not required to be part of the domain to host DNS information for the domain. They're not even required to be trusted to host DNS information. DNS and AD are separate services or separate functionalities. On a non-domain controller, you can only host standard primary or standard secondary zones. Standard primary zones, you have one server that is allowed to write to the text file to make changes to this DNS zone. Standard secondary servers receive changes to the zone via the zone transfer process from other DNS servers, whether those other DNS servers are primary for the zone or secondary for the zone. They don't all have to go to the primary to get these changes. If the machines that are hosting the zones are domain controllers, you can convert the zone to an AD integrated zone. When you make the zone AD integrated, what you are doing is creating objects in the domain partition for that domain that represent all of the records in DNS. And DNS will load its data from Active Directory. This now gives you the ability to support multi-master updating of DNS. Instead of the primary DNS server being the one DNS server that gets to make all the changes to the zone, any DNS server / domain controller can write to that DNS zone, propagate the information out via the normal replication process for Active Directory. This also allows you to secure updates to the DNS zone, where a machine does not get to modify records it doesn't own. So a client computer that says, I am Jim Bob Billy Joe Computer, if he wasn't Jim Bob Billy Joe Computer when that record was created, somebody else created that record, this machine is not going to be able to modify it. Helps prevent, provided you set it up properly, corruption of DNS, whether intentional or accidental. What else? This will change as far as the partition information that I gave you. As I mentioned earlier, in .NET they've added the application partition, which allows you to specify which domain controllers in your forest you want to host this partition. Therefore, you could have an AD integrated DNS zone replicating to domain controllers for multiple domains. In Windows 2000, however, because it is part of the domain partition, you need to be very aware of this topology when you make the AD integrated zone AD integrated. Integrate it in the domain where you want the data to be most stored or most updated, and set up other domain controllers that are DNS servers as secondaries if you want them also to be authoritative for the data. They will store it as standard text file, they will get updates, but they cannot write to the zone. DNS server placement, you should have at least one DNS server in every site, preferably more than one. Excuse me. DNS servers do not have to be domain controllers, as I mentioned, even if you're using AD integrated zones. For my production domain, I could have the DNS zone for that domain AD integrated in my production domain or even in my root domain. And then the other domain can get that information via the zone transfer process. DCs can run DNS zones that are both AD integrated DNS zones and standard DNS zones. So you're not limited. When you convert a single zone to AD integrated on a domain controller, it has no effect on any other DNS zones. So you could have 150 zones and only one AD integrated. DC/DNS servers for a domain should be secondary for AD integrated zones they don't own. If I have two domains and I have created for my production domain an AD integrated DNS zone that is replicating amongst the production domain DCs, I should make sure that my root DC/DNS servers are secondary so that they are authoritative for that zone instead of them having to point to my production environment. Placement of AD integrated zones. Where are you going to integrate these zones? This is something to consider since it is part of the domain partition. You may decide to make your root domain DNS/DCs be authoritative for all of your DNS domains. So I could have 5 production domains, take all of the DNS information, store that in my root domain as AD integrated zones in the root. One of the reasons you may want to do this is because the fact that the domain controllers in an empty root aren't doing a whole lot of anything. They're kind of sitting there performing a little base functionality, but they're not getting queried a lot, they're not authenticating anybody, they're bored. So you may want to consider hosting those zones in that forest root. Because of the fact that you're very accustomed to securing the forest root domain controllers, this helps ensure that you're also securing your AD integrated DNS zones. You may then take your DNS servers for other domains and make them secondary to the domain controller / DNS servers in your root. This is not the only way to go, it's just one option. You may also decide to place all of your AD integrated zones in a production domain. Have you heard about the DNS island problem? Nobody? Okay. It's a known issue, and my personal feeling is if you don't screw up in the first place, you probably won't encounter it. But when you build your forest root, when you build your very first domain controller and you make it a DNS server and you AD integrate the zone for that domain, if you point it to itself as its DNS server, and then you start adding additional domain controllers, and you change the IP address on that first server, it doesn't have any way to tell everybody else that it's not where it's supposed to be anymore. They can't find it, and replication breaks. This is a very long way of saying don't do this. Don't change IP addresses on your root DCs in the first place. Second, consider not pointing them to themselves, and it's specific to the root domain. I could go into a much longer description, but I'm going to run out of time. You can avoid this first by not changing IP addresses in your root on your domain controllers, at least not until you've got a clean replication topology set up and a clean DNS topology. And one of the things I always do before I start building Active Directory is make sure DNS is clean. I set up a standard primary, secondary topology and later convert to AD integrated after I know that everything is working cleanly via standard, secondary, and primary. With this said, if you store all of your AD integrated, all of your DNS zones in a production domain, you're going to point your root DCs to production domain DNS servers, domain controllers, as their DNS servers. So they will register themselves in that domain. The domain controllers for your production domain will know everything about all of the domains, including the forest root, and you avoid this island issue. Things to be aware of: DNS zones are accessible by several groups in the domain. This can affect your security configuration. DNS admins, which is a built-in group, have capabilities over DNS zones. Depending on how you set up DNS as far as updating and as far as what DHCP does, this can affect security of zones, which I think is coming next. Secure dynamic updates. Once you've implemented AD integrated DNS zones, you can enable secure dynamic updates where nobody gets to update the zone information without valid or Kerberos authentication. DNS records are then created as objects in AD with ACLs and with owners depending on how you configure this. Records cannot be updated by machines that do not own the record unless those users or other machines have permission. So if computer A registers itself in an AD integrated DNS zone, computer B cannot present itself as computer A and modify that record. It is not the owner. It doesn't have a valid ticket. There is a group called the DNS Update Proxy Group. Have you been using this? Okay. If you enable secure dynamic updates, the DNS Update Proxy Group allows DHCP servers to register client information in DNS on behalf of the clients. And what it does, so that the DHCP server doesn't become the owner of the record, is that object gets created with no owner. The first entity that touches that record becomes the owner, whether it's the appropriate machine or not. So this can be a security risk. DHCP servers should not be domain controllers because of this, because in general they shouldn't be domain controllers, but you should not be running DHCP on your domain controllers. You should be very concerned about the ownership of these objects. Organizational unit design. Very base recommendations when you're designing OUs. OUs do not necessarily, in fact quite often do not at all, represent the geography of your organization. Your upper level OU should represent who's responsible for what. Where are the areas of administrative authority in your environment, whether that's divisional, departmental, whether you have server teams, workstation teams, and so forth. Lower level OUs are typically designed for application of group policy, to group together machines and users with common configuration needs that are all administered by the same administrative group. You may want to consider creating a group policies OU, and what I mean by this is if you've looked at group policy, when you bring up the properties for an OU or a site or a domain and go to the group policy tab, you can create a new group policy there. Well, when you do this, if you're looking for group policies to link them in your environment, it's very difficult to figure out where they've gone. It's fairly common for companies to create a group policies OU to have a very restricted group of people who are allowed to create group policies at all. They link all of these group policies to the group policies OU so that other administrators in the company who do not have permission to create group policies but do have permission to link them to their piece of the organizational unit structure can go to one spot and pull down the policy. And what this allows you to do is set up a process by which if I want a group policy for my users, I requisition one. I say I want this, that, and the other thing applied to my users. My people who are responsible for creating group policy create the appropriate policy, link it to the group policies OU, I browse to it, pull it down, link it to the OUs in my environment. This also helps eliminate a lot of the headache in terms of what happens when you modify a group policy and it's been linked to multiple containers and now it's affecting those other containers as well. Because you have a central group of people doing all of the modification and creation of the group policies, you avoid a lot of that. It also prevents rogue admins from creating group policies that they think are going to lock you out of their environments. Domain controller concerns. Obviously, physically secure your DCs. If I have physical access to your DC, it's over, period. Whether I work for you or not, it's over. Do not install applications on DCs unless the application has to be on a domain controller. Don't put the resource kit on your domain controllers. Don't throw every toy and gadget and doodad that you play with on your DCs. Big security problem. Don't allow your administrators to locally access the DCs. The only time they should access those domain controllers, be in the server room, is when they have a very specific purpose, some application that requires them to physically touch that machine, or when they're swapping out hardware. And in .NET, you'll have totally headless servers. All remote admin. Do not give administrators domain admin accounts. This sounds probably kind of odd because that's why this group exists, the domain admins group. The problem is, as you know, I'm sure, you should not be logging on as domain admins or logging on to machines with administrative privileges. But domain admins have built-in capabilities in Active Directory that you may not want your administrators to have. What's a better idea is to set up roles in your environment, create regular user accounts for your administrative staff, and give them rights and permissions where they need to do things, and only for what they need to do. If you are going to allow physical access to a domain controller for some reason, require something beyond username, password, login, smart card, whatever it may be. I thought I had another slide. Yeah?
Could I use my Windows 2000 Terminal Services client with a smart card login? Can I do it without that server?
That remains to be seen.
Okay.
The question was, can I use my smart card to log in via terminal services or run as? You can't do it with run as. Will you be able to in .NET? Maybe. Don't know at this point. And actually, no. Hold on to that though. As far as these administrators, I'm going to give you a demo shortly on kind of a little glitch here. As far as these administrators, people who should be doing X, Y, and Z in your environment, rather than giving them administrative accounts that are members of administrators or members of domain admins, do some job task analysis. It's a huge pain. Nobody wants to fill these things out, but hand out spreadsheets and ask people, what do you need to do to perform your job? Their first response is always, I need to do everything. The reality is they don't. Ask them, do you need to format disks? Well, if you don't, then you don't need to do everything. Do you need to sit down at a domain controller? If you don't, then you don't need to do everything. Find out, do they need to be able to change permissions at the file system level and on what? Do they need to be able to unlock user accounts, modify user accounts? Once you have a list of what these people do in your environment, then design user accounts and groups that have these individual rights and permissions assigned to them, put the user into the appropriate groups, and give them administrative capabilities that way. but don't give them domain admin accounts. And here's why. Have any of you worked with trying to hide objects in Active Directory or have any desire to do so? You may want to hide things in AD from other admins. The reality is you can sort of make it look like you did, but you can't quite do it. If I go into, okay, here I have AD users and computers, domainred.corp. I've got this hidden OU. And let me bring up the users in question here. Where did I put them? Oops, here we go. IT administrative staff. These are my admins in Mechanicsburg, Pennsylvania. I have Jim Bob Billy Joe delegated tasks user. I have Jim Bob Billy Joe domain admin user who's a member of the domain admins group. And I have Jim Bob Billy Joe what I call local administrator, but what that means is he is a member of the administrators group. Now here's what happens. Jim Bob Billy Joe delegated tasks, all he has as far as his group memberships is domain users. Jim Bob Billy Joe domain admin is just a member of users and domain admins. So he's got those domain admin permissions. Now I have some terminal services connections set up for each of these users. In this hidden OU, if I bring up the properties for the OU, on the security tab, Big Bad Admin, who's me, I have full control over this OU. However, I took all of those Jim Bob Billy Joe accounts and I denied them everything. I don't want them to see the OU, I don't want them to modify the OU, I don't want them to know it exists. It's my secret OU. The system has full control. Now one of those users, Jim Bob Billy Joe domain admin, peruses AD users and computers. And this is all being done via terminal sessions, by the way. He goes into AD users and computers, and on domain red, he sees a hidden OU with an unknown object type. So far, it looks pretty good. He says, all right, what is this? I want to know. He brings up the properties, and he gets this kind of error. It says you can't see this. He goes to the object tab, can't see anything. Can't see the security information. So he says, you know, I've heard you can do this. He goes to the domain or to any other object to which he has permissions. He brings up the properties for this object and goes and looks at the security tab. That's all he's done. Cancels this out, goes back to a hidden OU, brings up the properties again. A little different this time. When he clicks on the security tab, it says, you can't see the permissions for this, but you can change them. So now he puts himself into the ACL, gives himself full control. It's his. He knows everything about your hidden OU, and it does work. So that's kind of a disadvantage to being a domain admin. It's a good thing and a bad thing. Now suppose I say, okay, I won't make these people domain admins, but I'll give them administrative capabilities on individual machines. Let me log off this guy. Oh man, oh phew, I thought I shut down. I was going to say crud. So I have this Jim Bob Billy Joe administrator. He's not a domain admin, he's just a member of administrators. I make Jim Bob Billy Joe this user instead of the domain admin because I figure I'm going to stop him from changing the permissions and putting himself into the ACL and seeing everything that's going on. So he's not a domain admin anymore. He comes in, he looks at this hidden OU, goes to the security tab, no dice. He knows his old trick. So he brings up the properties for the domain or for something else, goes to security, sees the ACL, cancels out, goes back to a hidden OU, goes to the properties, and this is a little different, goes to security. It says you do not have permissions to view the permission settings, but you can make permission changes. The reality is when he tries to do it, when he clicks apply or OK, it will fail, but he can go into the advanced settings and take ownership of the object, and when he does that, it will reset the ACL. And I would show you, but I want to show you the last person without blowing up my ACL first. On the other hand, if Jim Bob Billy Joe had been delegated certain permissions to maybe touch just one OU in this environment and do X, Y, and Z on servers in his OUs, when he goes into Active Directory users and computers and starts browsing around for things he shouldn't be looking at, he goes to this hidden OU, brings up the properties, can't see anything on the security tab, says, I know the trick for that. Brings up the properties for something he can see, goes to the security tab, gets this normal user information that says you're only allowed to read this, because that's all he has. He says, fine, I don't care, because that's not what I'm after in the first place. What I'm after is this OU. He brings up the properties for this OU. Now this is kind of funky. When he clicks security, it says you don't have permission to see these settings, but you can change them. So he clicks OK, and he adds himself in, and he's going to give himself full control. When he clicks apply, no dice. So by not putting him into those canned administrative groups, it is possible for me to restrict what he can touch and what he can see. But as long as he is a member of domain admins or a local administrator, as a built-in administrator, I can't stop him. He's going to be able, if he knows how to do this, to get around it. And I'll show you now what happens when he, as the administrator, starts poking in here. Jim Bob Billy Joe administrator. Goes to the hidden OU, nothing. Security says no dice. Brings up properties for anything, whoops, brings up properties in the security tab for anything else. Says cool, now I can get in here. Properties for the hidden OU says you can change, but you don't have the ability to see what's in there. So he adds himself in. Gives himself full control, applies, gets the error, says you can't do this. So he says, fine, I'll just take it. I'm going to change the owner to Jim Bob Billy Joe, this administrative guy. Shazam, it's his. Now he can do whatever he wants with it. In fact, if I have 5, it's an OU again. It's not an unknown object. And if I look at the ACL, look what happened. It's now back to inheriting permissions from its parent, which means administrators, enterprise admins, Jim Bob Billy Joe, because he put himself in there, and of course this pre-Windows 2000 compatible access. Clear? Okay. So again, perform job task analysis, see what people really need to do. Give them regular user accounts that have been granted and delegated, granted rights and permissions, and delegated control in Active Directory. Don't make them administrators, period. Summary, be very careful about where you place services, where you place servers, who physically accesses your machines, what accounts are being used for which things in your environment. And be very conscious of the enterprise admins, schema admins, because of the fact that they can very easily corrupt your entire forest. Day-to-day administration should not be performed using accounts that have true administrative rights, that are members of domain admins or local administrators on domain controllers. And again, local it's really built in. Okay, questions? Yes?
Are you aware of any, if not easy way, but maybe template method you could apply so that you could have a predefined set of administrative roles, and then taking each predefined set, create the proper permission?
I don't know of other tools for this. I'm sure they're probably out there, but one of the things that it does require some additional setup up front, but one of the things that, again, this company where we're very concerned about people not having full administrative capabilities, they've got 26,000 users, they have quite a few admins, and really none of these guys need to be domain admins. And what's fortunate is in this company they're pretty amenable to realizing that they've got to compromise what they can do sitting right at their machines. For them, we actually created groups, and each group is named according to what it has permission to do, and it's just one permission per group, or one right per group. So people who are allowed to reboot servers, they're in the reboot servers group. And by creating all of these groups, which is where the upfront work comes in, when you have an administrator who fills out the job task analysis and he needs to be able to do X, Y, and Z, you put him into the X group, the Y group, the Z group, his user account has those capabilities, and you're good to go. Now that's for user rights. As far as the OU level, you use normal delegation processes and have another group, delegated admins for this OU. Also, it was in the slides, but I don't think I mentioned it. Make sure that you don't leave the sort of administrative accounts in the OUs to which you delegate permissions, because you just gave them the ability to compromise and to elevate what they can and cannot do by doing that. That was why, if you look at my quickly made last night OU structure, I have a separate OU for my IT administrative staff, and what they're responsible for is the different regions underneath. Their user accounts don't live where their authority resides. And for those, what we typically would do is create a group called Delegated Full Control this OU. Delegated Create User Accounts that OU. Did that answer your question?
98%.
Okay. Other questions? None? Yes?
The exploit that you showed us, what I call an exploit, was that purposely built in? Is it a backdoor? Or is it
I really don't know if that was purposely built in, but I would consider it a backdoor. It's been there, it's not been changed in any service packs. I imagine it's by design.
Administrators have always been able to take ownership.
Sure, sure. They've always been able to take ownership, but the part that is kind of strange is the ability to bring up the property sheet for another object in the directory that you do have permission to see the security tab, and you can now do it for something where you didn't before. That is kind of the strange function. This machine is completely up to date on patches, updates, service packs, and you can still do it.
Do you think that there are possibly other things going on? I mean, you should be able to build a tool that administrates Active Directory without using Enterprise Manager, because even though the LDAP isn't open, you can write tools and just write. So
Sure.
do you think that there's possibly a lot of other things that aren't being enforced, that only this console enforces its security? You see that as a big black hole?
I have concerns about it, yes. I don't know to what extent a lot of this stuff goes as far as if I were building my own tools. But yeah, I do see that as a concern. I wouldn't necessarily say a security hole because of the fact that Microsoft has always been very upfront about saying in Active Directory, the people that you give these administrative capabilities, you're supposed to be able to trust them. That's an inherent structural part of Active Directory. It's not like NDS where if you don't like the other admin, you can lock them out, where you can cut them off at the knees. Their response is going to be, and will continue to be, if you're putting people in these positions where they're members of those groups, then it better be because you trust them and you're not trying to hide things from them. But where this does become a problem is where people say, well, you guys are administrators, we'll put you in domain admins or we'll put you in the administrators group because it's simple. Well, you've just given those people that ability. So in that respect, yeah, I consider it a security concern. I don't think if you properly implement, as you saw with the delegated tasks guy, you can't do it.
Is there any extra work in adding security to the auditing that you put on your objects in Active Directory? Like, you need to make sure that a user can, say, delete the auditing after it's happened. You need to make sure that they're indifferent to what OUs.
As far as who manages auditing in general?
Well, if you had an admin, not a domain admin, you're, say they can only reboot servers and format disks. They won't be able to change the auditing that's happened on this.
Correct, because that's a SACL as opposed to a DACL. It's a system access control list versus a discretionary access control list. Yes. Other questions? Did you get anything new out of this? Cool. That was my concern. When they approached me, I said, you know, I don't know if I'm ready for this audience. I don't have anything that interesting to say. And they said, oh, don't worry about it. Yeah, I thought, well, you know, I feel much more comfortable now. I'm ready. If there aren't any other questions, I think we're done. Thank you.